Welcome to the course on Python for data analytics, machine learning, and generative AI. Today, we will explore one of the most important technologies behind modern artificial intelligence. Many AI systems that we use today, such as chatbots, virtual assistants, and AI writing tools, are powered by large language models, often called LLMs. These models can understand human language and generate responses that sound very natural. But how do these systems work? What technology makes them so powerful? The answer lies in a special type of neural network architecture called the transformer. In this module, we will learn what large language models are, how they understand and generate language, what transformers are, and why transformers are important for modern AI systems. And let us begin with the basic idea of large language models. Generative adversarial networks, or GANs, can generate highly realistic images and videos that appear authentic. However, this capability also arises serious ethical concerns, especially with the creation of deepfakes. Deepfakes can be misused to spread misinformation, manipulate opinion, or damage reputations. Because of these risks, it is important for the industry to develop responsible AI policies. At the same time, better tools are needed to detect and identify AI generated and manipulated content. The term transformers and large language models or LLMs are often used interchangeably, but they actually represent different things. A transformer is the underlying neural network architecture that processes sequential data efficiently. You can think of it as the engine or blueprint that powers advanced AI systems. On the other hand, LLMs are the final AI application that are trained on massive data sets to understand and generate human-like text. In simple terms, the transformer is the technology, while the LLM is the product built using that technology. What are large language models? Large language models are advanced AI systems designed to understand and generate human like text. They are trained on vast amounts of data, including books, articles, and websites. One key feature of LLMs is their scale, often involving billions of parameters that help capture complex language patterns. Another important factor is the diversity of training data, which allows the model to learn different writing styles and topics. Because of this training, LLMs can perform many tasks such as answering questions, generating content, and assisting with codes. Their ability to generalize across tasks makes them powerful tool in modern AI applications. The transformer architecture is the revolutionary neural network design introduced in the 2017 research paper Attention is All You Need. One of its key features is self-attention, which allows the model to evaluate the importance of different words in a sentence at the same time. Another advantage is parallel processing, enabling transformers to process many words simultaneously rather than sequentially like older models. Because of this, transformers are faster and more efficient than traditional recurrent neural networks. Their flexibility also allows them to work in many domains, including language processing, image recognition, and time series analysis. Most modern large language models are built using the transformer architecture and their foundation. You can imagine the transformer as the base platform, while LLMs are the systems constructed on top of it. This architecture supports not only language tasks but also applications in computer vision and speech recognition. Although LLMs can technically be built using other architectures, Transformers have become the industry standard because of their performance and scalability. This relationship explains why transformers play such a critical role in today's AI technologies. Let us compare large language models and transformers based on their purpose and design. The core purpose of LLMs is to generate and understand natural language, enabling systems to produce human-like responses. In contrast, transformers focus on processing sequential data using a specialized neural network structure. LLMs can be built using different architectures, but most modern systems rely on transformers for efficiency and scalability. Therefore, transformers define the architecture, while LLMs represent the application built upon it. Large language models require massive datasets and significant computational power for training. Through this training process, they learn patterns in language and generate human-like text responses. Transformers, however, are not limited to language. They are adaptable frameworks that can work with many types of sequential data. Depending on the task, transformers can produce outputs such as text generation, numerical predictions, or image classification. This flexibility is one of the key reasons why the transformer architecture is widely used in modern AI systems. Large language models are useful when we need systems that work with human language. One common use is natural language generation, such as writing articles, blog, post, or chatbot responses. They are also powerful for language understanding, like analyzing sentiments or summarizing long documents. LLMs can perform text completion, predicting the next words in a sentence, or suggesting code in an editor. Another important application is question answering, where AI assistants provide answers from large collections of text. These capabilities make LLMs valuable in customer support, research tools, and intelligent assistants. Transformers are a neural network architecture designed to process sequential data efficiently. They are used when working with time-based or ordered information such as text, stock prices, or biological sequences. Transformers allow parallel processing, which makes training faster on very large data sets. They are also widely used to build custom AI models for tasks like translation, image captioning, or summarization. Because of their flexibility, transformers support general purpose learning across different domains. Today, they power many modern AI systems in language, vision, and multimodal applications. Several well-known transformer models are widely used in real-world application. BERT focuses on understanding context from both directions in a sentence and is useful for classification and entity recognition. GPT models use a decoder architecture and are designed for generating coherent text. T5 converts many NLP tasks into a single text-to-text format, making it very versatile. VIT or Vision Transformer adapts the transformer architecture for image processing tasks. Robota improves on PERT by optimizing the training process and data usage. Large language models have grown rapidly in size and capability. GPT-3 is a well-known generative model with billions of parameters that can produce human-like text. Llama, developed by Meta, focuses on efficiency and strong research performance. Turing NLG, created by Microsoft, is designed for advanced conversational and creative writing tasks. PALM, developed by Google, supports complex reasoning across many languages and domains. These models demonstrate how powerful LLM technology has become in modern AI systems. Let's summarize the key difference between large language models and transformers. LLMs are designed to generate and understand human language. Most LLMs are built using the transformer architecture, which provides the underlying framework. Transformers use self-attention and parallel processing to handle sequential data efficiently. LLMs are mainly used for tasks like text generation, summarization, and conversation. In simple terms, transformers are the architectures and LLMs are large models built using that architectures. Understanding the distinction between the model and the architecture is just the beginning. The true power of the modern AI landscape lies in its evolution, where architectures like transformers and models like LLMs are continually refined, combined, and expanded to tackle increasingly complex global problems. Thank you.